Welcome to this explainer. Look, today we are diving straight into the nitty-gritty of industrial busbar bending machines. We've got our hands on some incredibly insightful, real-world expert data straight from the engineers over at PayAPress. So if you're planning a capital expenditure for your workshop, or honestly, if you just want to understand the exact variables that drive industrial machinery costs, you're in the right place. We're going to decode exactly what you are paying for, and more importantly, figure out how to ensure you're making a genuinely smart, long-term investment. I want to kick things off by posing this core question to you. What is the real price of busbar production? I mean, it seems like it should just be a simple number, right? But here's the absolute truth. Looking only at the initial sticker price is literally one of the biggest traps you can fall into when planning a capital expenditure. A price tag only tells you what it costs to get the machine onto your factory floor. It tells you absolutely nothing about what it's going to cost you to actually run it, maintain it, or the cash you might bleed through daily inefficiencies. Okay, let's dive into this. We're going to follow a really logical path today. First, looking beyond that sticker price. Second, breaking down the three bending machine tiers. Third, a heads-ahead of hydraulic versus CNC systems. Fourth, calculating your total cost of ownership. And finally, leaving you with a concrete buyer RFQ checklist. All right, section 1, beyond the sticker price. Now, what's really interesting about this slide is seeing exactly why evaluating machinery requires looking way past the invoice. That purchase price, it's just one slice of the pie. Your real cost is dictated by hidden operational variables. We're talking tooling options, operator time, maintenance needs, and, crucially, scrap and errors. This is exactly why two machines with the exact same bending capacity can carry vastly different prices. One might literally just bend metal, while the other reduces material waste and drastically cuts down on your operator's handling time. Let's look at this insight directly from a PayAPress technical expert. Comparing prices without checking the machine's real specifications can lead to inaccurate budgeting and poor purchasing decisions. Investing in a machine with stronger tooling, rock-solid hydraulic components, and highly user-friendly controls isn't just about springing for luxury features. It is fundamentally an investment in your long-term efficiency. You're buying consistency here, and consistency is exactly what protects your profit margins over the long haul. Moving right along to Section 2, the three bending machine tiers. Let's move to and see how this builds across three escalating tiers of capability and investment. We start with manual and portable setups, step up to mid-range hydraulic machines, and finally arrive at CNC and advanced processing systems. Every single workshop fits into one of these steps based on their daily workload. First up, we've got the manual and portable setups. These are the most economical options you're going to find. They are absolutely perfect for light-duty work, quick repair jobs, or on-site electrical panel adjustments. If you're running a small workshop or a maintenance team that only occasionally needs basic forming capacity, this is your sweet spot. You definitely don't need to drop a massive budget on a full workshop machine if you're only bending a few copper bars on location. But say your volume increases. Enter the mid-range, hydraulic setups. These are the absolute daily workhorses for so many electrical panel builders and switchgear manufacturers. A lot of these are 3-in-1 machines, meaning they bend, punch, and cut copper or aluminum all in one compact unit. You get incredibly strong performance and high reliability, but with a highly accessible initial investment compared to the fully automated systems. And finally, we reach the top tier, CNC and advanced processing systems. Yes, these require the highest initial investment, but they are purpose-built for manufacturers dealing with large, professional quantities. Here, you're getting programmed bending sequences and multi-axis control, meaning the machine manipulates the metal in multiple directions without someone having to manually flip it. Because you can use offline programming and combine processes into one automated workflow, you drastically save floor space and effectively eliminate manual adjustment errors. It is all about maximizing that production flow. All right, Section 3, hydraulic versus CNC systems. Let's compare them. And this brilliantly illustrates the big choice you have to make. On the left, hydraulic machines, simple, fluid-powered strength, and highly affordable. They are ideal if you're running steady, repetitive parts and you've got a skilled labor force that knows how to handle the machine. On the right, CNC machines. These utilize precision motorized servo control, offline programming, and incredibly tight tolerances. CNC totally shines when you have frequent job changes and need to prioritize automated, traceable accuracy over relying entirely on manual skill. Regardless of whether you choose hydraulic or CNC, specific add-ons are what push a machine from one budget bracket into another. Capacity, like maximum width and tonnage, is a huge factor. Then there's tooling. Adding special U and Z-shaped molds saves immense time. Upgrading accuracy with digital encoders, which are essentially highly precise digital sensors, gives you consistent mark-free bends. Adding CAD/CAM design software, invisible safety light curtains, or requiring specific international compliance paperwork like CE, ISO, or UL, all of that factors into the final invoice. It's a highly customized purchase. Section 4. Total cost of ownership. We really need to shift our mindset away from just that initial capital expenditure and look at the actual operational reality of the factory floor. Total cost of ownership, or TCO. This is a life cycle costing approach that evaluates equipment over its entire service life. We're talking energy consumption, tooling wear and tear, maintenance, operator training, and the absolute killer of all profits, machine downtime. Actually, the U.S. National Institute of Standards and Technology's Handbook 135 provides standardized methods to validate this exact approach for comparing capital equipment. You literally have to look at the whole lifespan. So the crucial point is this formula right here. To calculate whether a more expensive machine is actually worth it, use this brilliantly simple math. Payback equals capital expenditure divided by your labor savings plus your scrap and rework savings plus your changeover savings. This translates the abstract concept of value directly into actionable, bottom-line math for your business. Let me give you a real-world scenario of how powerful that formula is using the number 30. If upgrading to a CNC machine saves you 20 to 30 labor hours per month, and its precise digital encoders drastically cut down your scrap materials and rework, well, that extra upfront cost doesn't take decades to pay off. It can return your investment in a matter of months. When you actually run the math, the more expensive machine can often be the cheaper machine to own. Crazy, right? Finally, Section 5, the Buyer RFQ Checklist. Take a screenshot of this moment. Seriously, if you're ready to reach out to vendors, this checklist based on PayAPress expert recommendations is your blueprint. Specify your exact materials, maximum width and thickness for your copper or aluminum. State your accuracy needs, like a plus or minus 0.5 degree tolerance. List the exact tooling dies you require, like L, Z, or U dies. Iron out your software needs. And don't forget the commercials, like Incoterms, which dictate international shipping responsibilities and warranty response times. Using this exact checklist ensures that when you get prices back, you are comparing apples to apples with zero hidden surprises. As we wrap up this explainer, I want to leave you with this final provocative thought. Which machine truly matches your future growth? Don't just buy for what your workshop is doing today. Buy for the volume, the precision, and the efficiency you want to achieve tomorrow. Look beyond the price tag. Run your total cost of ownership math and critically evaluate which equipment tier will actually be the foundation of your long-term success. Thank you so much for joining me to decode the real cost of Busbar production. Keep building, keep optimizing, and I'll catch you next time.